All right, so looking at today's objectives, guys. Again, I know McKinley got mad at me yesterday. You don't have to write down the objectives. I just want to visit them. Now you guys know.
She's not done them.
So, when we look at today's, basically, guys, what you're going to be asked to do for the assessment for today is be able to identify what the property of equality is. What those are here in a minute. And then, obviously, complete an algebraic proof. That's our goal for today. Just those two things. So, guys, this is information you have seen time and time again. Almost every single year in math class, we revisit all of these definitions. I'm not going to expect you guys to remember them right now, but I do expect that you remember them again today. Because once again, we'll revisit the same wording. Now, obviously, I think you guys can tell me about the distributive property. I think that's one that you guys should all know. What is distributive? Tori? Okay, so what does that look like? Okay, the first step, okay. Alright, so Tori says, hey, look at my work I did on the board. So we've got 3 times 2x minus 4, and that would equal 6x minus 12. Okay, that's distributive property. Where I'm literally taking the coefficient and distributing it to every single term inside the parentheses. Okay, that's distributive property. What does it mean to be symmetrical? What does it mean to be symmetrical? Your face. Perfect, Brandon. What does that mean? Yeah, like exactly. They can fold it in half, right? Okay. So, and again, it's kind of like what Tori said. Algebraically, when we talk about symmetric property, it's going to be the same equation, but it gets flipped. Okay, it's a flipped image. So, for example, I might say that 3x equals 15, which then, so if 3x equals 15, then 15 is equal to 3x. That's the symmetric property. I'm switching the order, flipping it around. Now the reflexive property, and I will agree with you guys, there's a lot of these, I call this the duh statement. And we see a lot of these in groups. Literally is the duh statement. And the way to think about the reflexive is the way I look at it is what you see is what you get. So if 3x equals 15, then, well, actually don't scratch that.
Oh, right in your head.
We'll just say that 3x is equal to 3x. That's the reflexive property. What you see is what you get. It's the same exact thing on both sides. And that's the reflexive. Now the transitive, a lot of times students will look at transitive and say substitution, and it kind of is. But it's a more powerful substitution, but it kind of goes like this, and it gets a little tricky in the wording here. So if A is equal to B, and B is equal to C. So notice with transitive property, I have 2 equations, and now I'm going to merge them together. So now let's think about this logically. If A is equal to B, and B is equal to C, then A is equal to C. Okay, and that's the transitive property. Now we have some other ones that are kind of ridiculous.
Yeah.
Now, I want to put a couple words out to you guys, and that is the identity versus the inverse. Wow. Identity versus the inverse. Because when we're talking about the identity property, what that does is it pretty much puts things back the way they were. So think about that term additive. What does that imply? Addition. What do I add to something so that it doesn't change? 0. Okay, so the additive property looks like this. If I have A and I add 0 to it, what do I get? I get A. It doesn't change. So the identity, gentlemen, does not change the value. So anything you add 0, that's the additive identity. The inverse, think about a classic way of solving an equation. How do you cancel out a term? So, okay, let me ask you this. If I had -3, what do I do to cancel out the -3? Add 3. If I have 5, what do I do to cancel out the 5? Okay. So guys, the additive inverse. And what's my result? My result is 0. That's the whole concept of the additive inverse. I'm adding something to cancel it out. So which means that it's A minus A is 0. Yes.
Is it always equal to 0?
Additive inverse will always add up to 0. Always. Because again, think of it, the inverse cancels it out. Okay, it's what we're adding to cancel out the term.
So it would be smart to just put all of the
All right, now, guys, what does the identity do again? Keeps it the same, right? What do I now again? Multiplicative. It's kind of a fun word to say. Multiplicative. Guys, what does multiplicative imply? What are we doing? Multiplying. So anytime I multiply by 1, that's called the multiplicative identity. So that's pretty standard. Now the multiplicative inverse is a little trickier. And I want us to go back to, I'm just going to bring up a general equation here. What if I had 3x equals 15? What do I do to solve for x? Divide by what? 3. When I divide by that 3, what do I get right here? I get a 1x equals 5. Now, what's important here is now that we're looking at that 3 over 3, is really, it's 1/3 times 3. These are multiplicative inverses. So what is a multiplicative inverse? It's really just the reciprocal. Okay, so you might want to make that a special note. The multiplicative inverse is a reciprocal. And if I take something, multiply by its reciprocal, my outcome is 1.
You got this, man.
No, I don't.
You just heard it.
Okay.
I get it, but I don't.
All right, so
That makes sense.
we'll see that through more examples later. All right. And then, guys, I'm not going to spend much time on this slide. This is all pretty standard. If I add something to both sides, it's called the addition property. If I subtract from both sides, it's subtraction. Same with division and multiplication. Those are pretty standard. I don't think we need to spend any time going over that. So let's look at first example 1. Five equals 3x minus 4, and 3x minus 4 equals 5. So, Lucas, which property is that?
The reflective one.
Okay, if it's reflexive, it'll be the same exact thing. This would be symmetric. Brandon, what about number 2? If the measure of angle 1 is 90, and the measure of angle 2 is 90, then the measure of angle 1 must equal the measure of angle 2.
Is it transitive?
That's transitive property.
Yeah, be large.
Alexa,
Yeah.
number 3, if the measure of angle 1 plus 30 is 90, then the measure of angle 1 equals 60. Okay? Guys, the question to ask yourselves is what changed? What do you think we did to get to that last part of the measure of angle 1 equals 60? What do you think, Alexis? What did we do there? What? Okay, so we're looking at number 3, right? Okay, and I have this. Angle 1 plus 30 is 90. What did I do to get to the result of angle 1 equals 60? Well, it's not we're actually doing something here. What's missing from this side to this side? Well, what did we distribute? Okay, how did I distribute the 30? Patrick, what did we do? We subtracted 30. So this is actually a subtraction property. So guys, I don't know, a lot of you guys could miss that there. But that, remember, we are subtracting 30 from both sides. And that gives me my result.
That is the next one.
You go ahead, Ivan. What's my last one?
Distributive.
That is not distributive.
Come on, I wrote down the D and everything. Oh wait, not distributive. Substitution.
No, not even close. Caleb, it's division property.
God dang it! Now I look stupid.
Oh, you are.
That's alright, Ivan. We all make mistakes.
Everybody has many.
Alright, any questions on that?